the awakening of the galaxy's past. In the beginning, there was darkness, a silence so vast and deep that even time itself had not yet begun to whisper. Then, out of that silence, the universe ignited. A brilliant, unrestrained flash of creation, the Big Bang. From that moment forward, the cosmos began its long and restless journey toward complexity. Billions of years later, somewhere amid the infinite sprawl of expanding space, a spiral of light would take shape, a galaxy we would one day call home. But the Milky Way was not born as we see it now. Its serene swirls of starlight, its tranquil bands across the night sky, are the result of violence, of collision, of cosmic evolution on a scale beyond comprehension. To truly understand our galaxy, we must go back, far beyond the birth of our sun, beyond the rise of Earth to an age when the universe was young, turbulent, and wild. This is not merely astronomy, it is archaeology on a galactic scale. Each star, each fragment of dust, each faint shimmer of light in the void, a fossil of time itself. Imagine standing before an ancient ruin, brushing away sand to reveal traces of forgotten civilizations. Now imagine doing that not with stone or pottery, but with starlight, tracing patterns across billions of years to uncover how our home in the cosmos came to be. The Milky Way began as a faint congregation of matter, born from clouds of hydrogen that filled the early universe. Gravity, the universe's invisible sculptor, gathered this gas into the first tiny clumps. Within them, pressure and heat ignited the first generation of stars, vast, short-lived giants that burned furiously and died violently. These were the architects of all that would follow. When they exploded, they scattered heavy elements, carbon, oxygen, iron, into the void, enriching the cosmos and seeding future generations of stars. Those early explosions were more than just endings. They were beginnings. They gave the universe the raw material to create complexity, to create us. Over hundreds of millions of years, those scattered clouds began to merge, drawn together by gravity's relentless pull. They collided, swirled, and combined to form ever larger structures. Eventually, one of those clouds, nestled in a dark corner of a vast cosmic web, would grow into what we now call the Milky Way. Our galaxy's formation was not a single event. It was a long, chaotic process, a story of accretion, collision, and transformation. Small protogalaxies merged like droplets of rain converging into a river. Each merger brought new stars, new gas, new energy, and new chaos. The Milky Way grew layer by layer, a living relic of cosmic evolution. If we could turn back time and watch, we'd see it glowing faintly in the early universe, irregular, fractured, glowing with bursts of star formation. The first stars flickered out quickly, leaving behind clouds of gas enriched with heavier elements. Over billions of years, these materials coalesced again, forming generations of stars more stable, more enduring, the ancestors of the sun and the stars we see today. To unearth this ancient history, astronomers act as cosmic archaeologists. Their tools are not shovels and brushes, but telescopes and spectrographs. They study the light from distant stars, decoding the elemental fingerprints imprinted within. Every atom tells a story, a record of when and where a star was born. By mapping these chemical signatures across the sky, scientists reconstruct the Milky Way's forgotten epochs, tracing its growth like layers in the walls, of an ancient cave. Deep in the galactic halo, a faint, ghostly sphere surrounding the Milky Way, lie the oldest surviving stars. They are dim, ancient, and unyielding. Their light has traveled for billions of years to reach us, carrying the story of a universe long gone. These stellar fossils reveal that our galaxy was built from many smaller ones. Each of those early galaxies contributed its stars, its dust, its dark matter, leaving behind subtle imprints in the Milky Way's structure. One of the greatest discoveries in recent astronomy was the identification of a galactic ghost, the remnants of a long-dead galaxy called Gaia Enceladus. Billions of years ago, this smaller galaxy collided with the young Milky Way. The collision tore apart its structure, scattering stars across the galactic halo. Today, astronomers can still see those remnants, faint streams of stars moving in strange orbits, like the scars of a forgotten war. These ancient remnants whisper of a time when the Milky Way was still forming, when the night sky was alive with collision and creation. Everywhere we look, we find evidence of these ancient mergers. Star clusters that move against the grain of the galactic disk. Rivers of stars stretching across space, the torn remains of galaxies long absorbed. The Milky Way, it turns out, is not a quiet, peaceful spiral. It is a survivor, a mosaic of many worlds, pieced together by time and gravity. As we dig deeper into this cosmic archaeology, we begin to uncover a larger truth. The galaxy's structure, its spiral arms, its central bulge, its halo, all arose from the interplay between matter, energy, and dark matter. Dark matter, the invisible scaffolding of the universe, shaped where stars could form and how galaxies could grow. We cannot see it, yet its presence dominates. It forms halos that cradle galaxies like invisible cocoons, binding them with unseen gravity. Without it, the Milky Way might never have existed. The visible stars are just the surface, the glittering dust atop a vast hidden mass. Through gravitational mapping, astronomers have traced this invisible skeleton, discovering that our galaxy sits within a halo of dark matter far larger than the disk of stars we can see. It is this unseen structure that guided the galaxy's growth, pulling in matter, directing its rotation, and preserving its form for billions of years. Every star we see tonight owes its place to that invisible web. The Milky Way's story is one of transformation, from chaos to order, from simplicity to complexity. But it is also a story of memory. The oldest stars, still burning faintly in the galactic halo, remember a universe that was raw and young. They are the witnesses of cosmic dawn, their light a direct message from the beginning of time. When we look up at the night sky, we see the Milky Way stretched like a river of light. Yet what we truly see is history, billions of years condensed into a single glowing band. Every star is a relic, every shimmer a chapter in a story written in hydrogen, helium, and light. The Milky Way is not static. Even now it moves, breathes, evolves. Its stars orbit a common center, a supermassive black hole known as Sagittarius A*. Around this dark heart, stars whirl in dizzying speeds, bound by gravity's grasp. This central black hole, millions of times more massive than our sun, is both a remnant of the galaxy's violent past and a guardian of its current stability. Though invisible, it shapes the motion of stars across tens of thousands of light years. And yet, even it was once smaller, born from the merging of black holes that predated the Milky Way itself. The further we explore, the more we realize our galaxy is alive with echoes. Streams of ancient stars, remnants of past collisions, magnetic fields twisting through clouds of gas, all whisper the same truth. The Milky Way is a living fossil, and we on our tiny planet orbiting a middle-aged star are part of its continuing story. To know the Milky Way's past is to understand our own origins. The atoms in our bodies, the iron in our blood, the calcium in our bones, the oxygen we breathe, were all forged in stars that lived and died long before the sun existed. We are, quite literally, the dust of ancient stars, fragments of a cosmic history written in light. In every breath and every heartbeat, the legacy of those ancient explosions continues. To study the Milky Way is to look inward as much as outward, to see not just where we are, but where we came from. And as we peer deeper into the galactic past, with telescopes that see across time itself, we begin to realize something profound. Our galaxy is not unique. There are billions like it, each with its own secret past, its own collisions, its own forgotten stars. But this one, the Milky Way, is ours, the one that gave us life, memory, and meaning. We are its archaeologists, and our dig has only just begun. The ghosts of galactic mergers. If you could drift high above the Milky Way, far beyond its luminous disk, you would see not a perfect spiral, but a galaxy veiled in streams of starlight, faint rivers winding through the darkness. These are the remnants of ancient galaxies, torn apart and absorbed over billions of years. They are the scars of creation, the quiet evidence that the Milky Way grew not in peace, but through conquest. Every galaxy tells a story of collision. Gravity pulls them together, and when they meet, their stars weave into new patterns. The Milky Way is no exception. In its youth, it was a restless collector, drawing in smaller galaxies like a cosmic predator. Each merger left behind stellar fossils, clusters of old stars moving in strange orbits, each one a clue to a vanished world. To unearth these vanished galaxies, astronomers have become detectives of motion. Using observatories like Gaia, which maps the positions and movements of over 1 billion stars, they can trace the subtle dance of stellar streams across the sky. Each star's path is a thread in the galaxy's memory, and when enough threads are woven together, a picture emerges. The evidence tells us that about 10 billion years ago, the Milky Way collided with one of its largest companions, a galaxy we now call Gaia Enceladus, or sometimes the Sausage Galaxy because of the elongated paths its stars now follow. This collision reshaped everything. The young Milky Way's disk was torn and heated, its stars scattered into new orbits, forming the thick disk that still surrounds us. The infalling galaxy was shredded, its stars becoming the faint halo we now see stretching far beyond the spiral arms. That event transformed our galaxy's destiny. Imagine it, 2 galaxies spiraling into one another, their stars passing like ghosts. No single star collides directly, but their collective gravity churns gas and dust into chaos. Shock waves ripple across thousands of light years, triggering storms of star formation. The night sky, if there had been any observers, would have been filled with blazing nebulae and newborn suns. The Milky Way, once small and irregular, emerged larger, brighter, and more structured. It was no longer a fledgling galaxy. It was becoming something grand. Even now, long after that cosmic battle ended, the ghosts of Gaia Enceladus remain. Astronomers can identify its former stars by their distinct chemistry, poor in heavy elements, rich in ancient simplicity. They move through the galaxy on tilted orbits, crossing the plane of the Milky Way like messengers from another era. They are the oldest survivors of a galactic war, still traveling paths carved billions of years ago. And that was only the beginning. After Gaia Enceladus came other, smaller galaxies that the Milky Way absorbed in its ongoing hunger. Among them were the Sagittarius dwarf galaxy, now being torn apart before our eyes, and the Helmi stream, another remnant of a long-lost companion. Each brought new stars, new clusters, and new stories. Even today, these fragments are still raining down, slowly merging, feeding the Milky Way's growth. The process is not over. As we speak, the Sagittarius dwarf continues its slow disintegration. Its stars form a great arc around the galaxy, wrapping it like a ribbon of light. And beyond, the Magellanic Clouds, two irregular dwarf galaxies visible from the southern hemisphere, are also being drawn closer. Eventually, they too will be consumed, their stars scattered into the Milky Way's halo, the latest additions to our galaxy's expanding archive. Through this endless cycle of destruction and creation, the Milky Way became what it is. Each merger mixed the gas and dust, enriching it with the ashes of older generations. With every collision, new waves of star birth ignited, seeding the galaxy with fresh suns, fresh worlds. The spiral arms we see today are the graceful afterimages of that ancient violence. When we look up at the night sky, we see peace, a calm river of stars stretching across darkness. But what we are truly seeing is aftermath. Every glimmer is part of a recovery story, the quiet equilibrium that follows chaos. Astronomers often describe the Milky Way as a galactic museum. Its disk and halo hold relics from every epoch, stars forged in the earliest clumps of gas, stars captured from invading galaxies, stars born after violent mergers. Each population carries its own signature, its metallicity, its motion, its age, like artifacts placed in different layers of sediment. And so, to read the Milky Way's history, we dig through these layers. The outer halo is ancient and poor in heavy elements, built from the remains of primitive galaxies. The inner disk is younger and richer, filled with the recycled debris of countless stellar generations. In between lies the thick disk, the fossil of that great merger 10 billion years ago. Together they form a stratigraphy of time, written not in rock but in light. At the core of this galactic story sits a quiet enigma, a supermassive black hole millions of times the mass of our Sun. It anchors the Milky Way, a gravitational keystone around which all else orbits. Yet even this central giant is a relic of mergers. Black holes grow by consuming others, and deep within Sagittarius A*, the Milky Way's heart, lie the remnants of many ancient collisions. In a sense, our galaxy's core is the ultimate archaeological site, a dark vault where the ghosts of long-vanished galaxies still linger. Far from the center and the outer halo, the story is different. Here, the density of stars drops, the light dims, and space becomes silent. Yet even here, faint trails of starlight stretch across the void, the remnants of satellite galaxies still being pulled apart. It is a realm of memory, the outskirts of a civilization built from countless forgotten ones. Modern telescopes like Gaia, the Sloan Digital Sky Survey, and the upcoming Vera Rubin Observatory are transforming our view of this region. They allow scientists to map the faintest structures, revealing how the Milky Way's halo is laced with the remnants of past mergers. Some of these stellar streams span hundreds of thousands of light years, wrapping around the galaxy like faded inscriptions on an ancient tablet. By studying their motion and composition, astronomers can reconstruct how the Milky Way grew, star by star, merger by merger. Each discovery adds another brushstroke to the grand portrait of our galaxy's evolution. We are learning that the Milky Way was not shaped by a single event, but by dozens, perhaps hundreds of smaller encounters. Some were so gentle they left barely a ripple. Others were cataclysmic, igniting whole epochs of starbirth. Over time, these interactions sculpted the spiral beauty we see today. Yet the universe keeps moving. The Andromeda galaxy, our nearest spiral neighbor, is drifting closer, pulled inexorably by gravity. In about 4 billion years, the two galaxies will meet. The collision will reshape the skies once more. The Milky Way and Andromeda will merge into a single colossal galaxy, a new structure that some astronomers have already named Milkomeda. It will mark both an end and a beginning, the last great chapter in our galaxy's long archaeological record. But that future collision is only the distant echo of a pattern that has been repeating since the dawn of time. Mergers build structure. Destruction fuels creation. Galaxies are not monuments. They are organisms growing, evolving, and remembering. And the Milky Way, our home, carries those memories in every star, every cluster, every faint trail of light that winds through the dark. As we continue to study it, we are not just looking outward. We are uncovering the story of existence itself, because the same forces that shape this galaxy also shape the atoms within us. Our blood, our bones, our breath, all forged in the same crucibles that blazed during those ancient collisions. We are, quite literally, the living record of the Milky Way's past. The camera of the mind drifts outward now, past the disk of the galaxy, into the halo where the last stars flicker like embers. Their light is old, but still traveling. Their story continues. And so does ours, mapping the invisible scaffold. There is a mystery woven into the fabric of our galaxy, something vast, unseen, and yet utterly essential. It does not shine. It does not glow. It cannot be touched, and yet it outweighs everything we can see. This is dark matter, the invisible scaffold upon which the Milky Way was built. Without it, the stars would drift apart, the spiral arms would unravel, and our galaxy would dissolve into the emptiness of space. To understand the Milky Way's secret past, we must learn to see what cannot be seen. Astronomers discover dark matter not by observing it directly, but by watching how galaxies move. In the mid-20th century, scientists like Vera Rubin noticed something strange. The stars on the edges of galaxies orbited far too quickly. According to the visible mass, the stars, the gas, the dust, they should have been flung into space. But they weren't. Something invisible was holding them together. Something massive. Something everywhere. That something became known as dark matter, a form of matter that neither emits nor absorbs light, yet exerts gravity all the same. And it doesn't just influence galaxies, it defines them. In the early universe, long before the first stars formed, dark matter began to clump together under gravity's pull, forming enormous halos, invisible spheres of potential. Within these halos, ordinary matter, hydrogen and helium, gathered, cooled, and ignited. That was how the first galaxies were born. That is how our galaxy began. The Milky Way resides within such a halo, a dark, spherical cloud of unseen mass that extends far beyond the luminous disk. It stretches hundreds of thousands of light years across, enveloping every star, every planet, every atom in an invisible embrace. We live deep within its core, unaware of the silent ocean of dark matter that surrounds us. Imagine it, an unseen structure, more than 1 trillion times the mass of the Sun, binding the Milky Way in place. It is the skeleton of our galaxy, a hidden architecture that shaped everything we know. Without it, there would be no spiral arms, no stable disk, no Sun, no Earth. And yet, this scaffold is utterly mysterious. We don't know what dark matter is made of. It may be composed of exotic particles that rarely interact with normal matter. It may exist in a form we have yet to imagine. But even without direct detection, its presence is undeniable. We see its fingerprints everywhere, in the rotation of galaxies, in the bending of light from distant stars, in the grand web that connects the cosmos. That web, known as the cosmic web, is the large-scale structure of the universe. It is a vast network of filaments made of dark matter and gas, stretching across billions of light years. Galaxies form along these filaments, like dewdrops clinging to invisible threads. Our Milky Way is one such drop, a bright knot in an endless lattice of shadow. If we could step outside the universe and look down upon it, we would not see a random scatter of galaxies. We would see structure, a web of light tracing an unseen framework of dark matter. This is the universe's true skeleton, and the Milky Way's story is one of its smallest, most intricate bones. By studying how galaxies cluster and move, scientists can reconstruct this cosmic architecture. They map the distribution of galaxies across the sky, revealing filaments, voids, and intersections. At those intersections where the filaments meet, dark matter halos grew large enough to form galaxies like our own. The Milky Way sits at one such crossroads, part of a small cluster known as the Local Group, alongside Andromeda, Triangulum, and dozens of dwarf galaxies orbiting in our gravitational field. All of them, the giants and the dwarfs alike, are connected by dark matter filaments, invisible bridges of gravity that thread between them. The more we study these structures, the more we realize that dark matter is not merely a background force. It is the cosmic architect, the planner of galactic destiny. The Milky Way's spiral form, its density waves, its satellite galaxies, all are shaped by that invisible mass. When smaller galaxies fall into the Milky Way's gravitational grasp, they don't just follow random paths. They are guided by the contours of the dark matter halo. Every merger, every orbit, every collision follows the silent geometry carved by this unseen substance. To visualize it, astronomers turn to simulation, digital universes built from equations and computation. Projects like the Illustris and EAGLE simulations recreate billions of years of cosmic evolution inside a supercomputer. What emerges is breathtaking. galaxies forming within halos of dark matter, colliding, merging, growing, just as the Milky Way did. And when scientists compare these virtual galaxies to real observations, they match almost perfectly. The universe, it seems, follows a recipe, one in which dark matter is the main ingredient. But dark matter does more than shape galaxies. It also preserves them. The Milky Way's rotation curve, the speed of stars around the center, remains flat even at enormous distances. That stability is what allows our spiral arms to persist, what lets the galactic disk remain intact across billions of years. Without the gravitational cushion of dark matter, the Milky Way would have torn itself apart long ago. Still, there are mysteries within mysteries. Recent studies suggest that the Milky Way's dark matter halo might not be perfectly spherical. It may be warped, twisted, shaped by ancient mergers and unseen tides. Its density may vary, its edges frayed by collisions with smaller halos. If we could see it, it would resemble a ghostly cocoon of lightless matter, diffuse, yet vast, glowing only in the imagination. And then there is the question of interaction. Dark matter does not seem to collide, to clump, or to scatter the way normal matter does. It passes through itself, through stars, through planets, even through us. Every second, trillions of dark matter particles may be streaming through your body, unnoticed and unfelt. You are immersed in it, bathed in it, sustained by it, and yet it remains forever beyond your touch. To many scientists, this is one of the greatest frontiers in all of physics. They build detectors deep underground, shielded from cosmic rays, hoping to catch even the faintest whisper of dark matter interacting with ordinary atoms. For decades, the detectors have waited, silent, patient, watching. No direct detection yet. But the search continues because the stakes are profound. To find dark matter would be to uncover the missing mass of the universe, the foundation of all structure, the key to understanding why galaxies exist at all. And while we wait, we continue to learn from its shadow. Through gravitational lensing, the bending of light by gravity, astronomers can trace the shape of dark matter halos by observing how they distort the light of background. These cosmic mirages reveal the invisible. By combining thousands of such observations, scientists have built the first maps of dark matter across the sky, ghostly outlines of the scaffolding that underlies all creation. In those maps, the Milky Way is just one node, a bright spark in an immense network. Yet for us, it is everything. It is home, cradle, and archive, bound together by dark matter's unseen hand. When you look up at the night sky, what you see, the stars, the nebulae, the spirals are only the ornaments on a vast invisible structure. The true Milky Way in all its mass and majesty lies hidden in shadow. We are children of that shadow, sculpted by forces we can feel but not see. Our galaxy's beauty, its order, its endurance, all flow from the quiet dominance of dark matter. It is the silent historian of creation, the keeper of cosmic architecture. And though invisible, it has shaped the path of every star, from the first to the last. The story of dark matter is not over. In fact, it may only be beginning. For as our instruments grow sharper and our questions deeper, we may yet learn to read the final layer of the Milky Way's fossil record, the unseen bones that hold the galaxy together. Until then, the invisible scaffold remains a mystery, a vast, elegant enigma reminding us that most of reality lies beyond sight. And in that darkness lies the blueprint of everything we know. Far from the crowded heart of the Milky Way, the spiral arms sweep outward like trails of ancient smoke. Within those arms, gas clouds drift, collapse, and reignite, repeating a cycle older than memory. Out here, the galaxy forges its newest generations of stars, and eventually worlds. The story of these stars is the story of everything we know. Each one is a furnace where the raw ingredients of existence are refined. In the earliest times, the universe knew only hydrogen and helium, lightest of elements, born in the Big Bang's first minutes. Everything heavier came later, built inside the hearts of stars. Within a stellar core, gravity squeezes matter until atomic nuclei fuse, releasing energy and forging new elements: carbon, oxygen, silicon, iron. When massive stars exhaust their fuel, they collapse and explode as supernovae, scattering those elements into the galactic sea. Their ashes seed new clouds, which collapse again to form new suns. Out of destruction, creation returns. Every atom in your body has taken part in this cycle. The calcium in your bones was made in the heart of a dying star. The iron in your blood once glowed in a supernova's shockwave. The oxygen you breathe was exhaled by generations of suns long vanished. The Milky Way has been building the ingredients of life for billions of years, not all at once, but through countless repetitions of birth and death, silence and fire. Roughly 5 billion years ago, one of those clouds began to collapse in a quiet region of the Orion Arm. It spun faster as it shrank, flattening into a disk of dust and gas. At the center, pressure rose until nuclear fire sparked and a new star ignited. That star was our sun. Around it, the remaining dust gathered into planets, moons, asteroids, the small debris of creation. Among them was Earth, a world that would one day look back and try to understand where it came from. The sun is not an isolated beacon. It belongs to a population known as Population I, stars rich in heavier elements, descendants of countless earlier generations. Its very existence proves how busy the Milky Way had already been. By the time our solar system formed, the galaxy was ancient, mature, layered with history. As the young Earth cooled, atoms that had traveled through billions of years settled into new patterns: minerals, oceans, molecules, life. The cosmic dust had become conscious. For the first time, the universe could look inward and see itself. Yet even as life began to stir on a small blue planet, the Milky Way kept moving. Stars continued to form, drift, and die. Spiral arms wound slowly through space. Giant molecular clouds collapsed, birthing clusters of suns that would live and perish long after ours. The galaxy does not rest. It breathes in epochs. If you could trace every atom's lineage, you would find it looping through time like threads in an infinite tapestry. Hydrogen forged in the Big Bang, carbon made in a red giant, nitrogen born in a supernova, all gathered again in the cells of a living creature, wondering how such a story could exist. Astronomers sometimes call this realization the cosmic genealogy, the family tree of matter. Its roots lie in the first stars. Its branches reach into every living thing. To study the Milky Way's past is to study our own ancestry on the grandest scale imaginable. Every chemical fingerprint in a star's light tells part of that genealogy. By analyzing starlight, scientists read a star's metallicity, how rich it is in heavy elements, and thus its generation. The old halo stars, poor in metals, tell of the galaxy's youth. The younger disk stars, abundant in complex atoms, tell of many cycles of renewal. Through this language of light, we can reconstruct when and where the building blocks of life became plentiful. Somewhere in that progression, the ingredients aligned. The Milky Way had brewed enough complexity for life to arise. Not only here, perhaps, but in countless other places. Every new star may host planets. Every planet a new experiment. Across the galaxy, there may be billions of worlds tracing their origins to the same cosmic foundry that made us. And yet, the scale of it humbles. Our sun orbits the galactic center once every 200 million years. Since its birth, it has made only about 25 revolutions around the core. In that time, species have evolved and vanished, continents have drifted, civilizations have risen and fallen, all while the sun completed less than a fraction of its galactic year. The Milky Way's timescale dwarfs our own. When we study meteorites, fragments of the early solar system, we find isotopes forged in distant supernovae. They are pieces of the galaxy's memory, preserved in stone. The universe leaves traces everywhere, waiting for those who know how to look. In the cold outskirts of the galaxy, far beyond the visible disk, ancient stars still drift in silence. Their light is weak but steady, unchanged for billions of years. They are witnesses to every era of the Milky Way's history. Around them, tenuous streams of gas form faint bridges between galaxies, carrying the ashes of long-dead suns from one system to another. Even now, the cycle continues. New stars ignite in nebulae like the Eagle, the Orion, the Carina, vast nurseries glowing with hydrogen fire. Around some of them, dust disks shimmer in infrared light, forming new worlds. Somewhere in those disks, chemistry may already be assembling the first fragile molecules of life. The process that created us is still unfolding. And within our own star, fusion continues quietly, turning hydrogen into helium, sustaining warmth and light. Every second, the sun loses millions of tons of mass as energy, but its endurance will last for billions of years more. When it finally dies, it will shed its outer layers into space, enriching the galaxy once again, closing one more loop in the endless exchange between star and dust, life and death, matter and memory. Everything we see, everything we are, is part of that cycle. The galaxy is not only a place. It is a process, one that began before time as we know it, and will continue long after our world. To understand this is to feel a strange mixture of humility and belonging. We are small, yet indispensable. Brief, yet eternal, through the matter that will outlive us. The Milky Way's story is written in the atoms of our bodies, and through us, the galaxy remembers itself. When you gaze into the night sky, you are looking not outward, but backward, into the deep layers of time. Each star is a message from a different chapter, some just born, some older than the earth itself. Together they tell the same story, the story of transformation. And so the cosmic archaeological dig continues, not with shovels, but with thought. Not in sand, but in starlight. The Milky Way is the grandest ruin of all, and within its dust we keep finding traces of who we are. As we near the present day, the Milky Way drifts onward through the dark sea of space, not alone, but surrounded by companions. Small dwarf galaxies orbit us like ancient satellites, remnants of those the Milky Way once absorbed. They are ghosts of long-lost worlds, their stars still moving along the scars of forgotten collisions. To modern astronomers, these faint companions are time capsules. Each holds clues to the Milky Way's ancient appetite, how it grew by consuming smaller galaxies, merging their stars into its own disk and halo. The patterns of those orbits, traced by instruments like Gaia, reveal the memory of every cosmic collision. It is as though the galaxy still carries the fingerprints of everything it has ever devoured. Far beyond the edge of our visible stars lies something greater, a vast invisible sphere known as the dark matter halo. We cannot see it, but we feel its influence in the way our galaxy spins. Without it, the stars would scatter into the void. It is the hidden architecture of the Milky Way, a silent framework holding everything together. No one yet knows what dark matter truly is. It neither glows nor absorbs light, yet it outweighs all visible matter combined. Some say it could be made of undiscovered particles. Others imagine it as a deeper property of space itself. Whatever its nature, it has shaped the Milky Way since the beginning, an unseen hand guiding its destiny. The Milky Way, for all its apparent stillness, is a restless being. Its spiral arms are not fixed. They ripple like waves through an ocean of stars. The galactic bar at its core rotates slowly, stirring the surrounding gas, triggering new bursts of star formation. Even now, thousands of new suns ignite each year, while others fade into white dwarfs or vanish into the silence of black holes. In the grand sweep of cosmic time, galaxies are alive. They are born, they grow, they merge, and they change. And our Milky Way, though magnificent and old, still has an unfinished story. About 4 billion years from now, a neighboring giant approaches, the Andromeda galaxy, visible even now as a faint smudge in the northern sky. It too is a massive spiral, moving toward us at a speed of roughly 110 kilometers per second. Their meeting is inevitable. When they collide, there will be no explosion, only the slow ballet of gravity over hundreds of millions of years. Stars will pass through one another without touching, but their mutual attraction will distort both galaxies, flinging streams of stars into vast arcs across the heavens. The black holes at each center will spiral inward, merging into a single colossal heart of darkness. For a time, the night sky of any surviving world will be breathtaking, a canvas ablaze with billions of new suns as the two galaxies entwine. Eventually, their chaos will settle, forming a new, larger galaxy an elliptical titan astronomers have already named Milkomeda. Our sun, if it still burns, will not be destroyed by this encounter. But by then it will be entering its final phase, expanding into a red giant, consuming the inner planets, possibly including Earth. Life as we know it will be gone, but the matter that once formed us will be carried into the next generation of stars. The story will continue, written in new forms, under new suns. It is humbling to realize that even galaxies have destinies. What we call destruction is simply transformation on a cosmic scale. The Milky Way has lived through countless such changes, and its next will be no different. Another act in an endless play of creation and renewal. long after the collision, long after the last star forms and the universe grows dark, the remnants of our galaxy will persist. Black holes, neutron stars, and the faint glow of dying suns will drift through the expanding void. Yet even then, the elements born in those stars, carbon, oxygen, iron, will endure, scattered across eternity, waiting perhaps to become something else once more. For now, though, the Milky Way remains vibrant. Within its spiral arms, nebulae still shimmer with life's raw ingredients. Astronomers peer deep into the galactic core, studying pulsars, exoplanets, and the dance of stars around the central black hole, Sagittarius A*, a monster 4 million times the mass of the Sun, yet invisible, its presence betrayed only by the motion of the stars it holds captive. In a sense, the galaxy is aware of itself through us. We, fragile creatures of dust and light, have become its memory and its voice. Through our telescopes, our mathematics, and our curiosity, the Milky Way has learned to look inward, to trace its origins, to imagine its future. Every discovery brings us closer to understanding not just where we are, but who we are. We are not observers standing apart from the cosmos. We are participants in its unfolding story. The galaxy is our home, not in the metaphorical sense, but in the physical one. Every atom within us was forged in its fires. Every breath we take resonates with its rhythm. The great cosmic archaeological dig continues, not in soil, but in the space between stars. Each new telescope acts as a tool, brushing away the dust of ignorance, revealing the fossils of ancient light. We study the faint halos of old stars, the streams of long-absorbed galaxies, the ripples in the cosmic microwave background, each a clue, each a whisper from the past. One day, future astronomers may unearth even deeper truths. The true nature of dark matter, the birth of the first stars, the mystery of what preceded the Milky Way itself. Until then, we keep searching, guided by wonder, and by the simple human desire to know. When you step outside on a clear night and look upward, remember that the light reaching your eyes has traveled across time, from stars born before humanity, before Earth, before even the Sun. You are witnessing the afterglow of creation itself. That light is ancient, but it is not gone. It lives on in you, in every heartbeat, every breath, every thought. You are the Milky Way, remembering its own past. You are the universe, becoming conscious of its own story. And as the stars wheel overhead, silent and eternal, the cosmic dig goes on, layer by layer, light by light, revealing that the greatest discovery of all is not what lies beyond the stars, but what connects us to them. Because in the end, the Milky Way's secret past is not just its own. It is ours.